This is Nick Castle and Ben Yarborough's lab view for problem 7 of Project Infinity Part 1. Here is the circuit diagram for the first problem. It is a NOT gate, also just to show that it can stop and start correctly. There we go. Alright, when no switches are on, the light is on. Switch 1 on, light goes off. For the second problem, that one is just an AND gate. So when no switches are on, it's off. One switch on, still off. Both switches on, it turns on. And when only switch 2 is on, it's off. For problem 3, this is the NAND gate. You can see it over here. When no switches are on, it is on. One switch on, it's still on. Both switches on, it turns off. And second switch on, it turns on. And that's just because it's the inverse of the AND gate. For 4, this is the 2-input OR gate. I made it out of 3 NAND gates connected like you can see in the diagram. When no switches are on, it's off. When switch 1 is on, it turns on. When switch 2 is on, it turns on. And when both switches are on, it's still on. For problem 5, this one is the 2-input XOR gate. I made this one out of 3 NAND gates, as you can see over in the circuit diagram, or logic diagram. When nothing's turned on, light is off. 1 is on, light goes on. 2 is on, light goes on. And when both are on, it turns off. And then for problem 6, this is the one constructed using the table here below the enum input. You can see the diagram over here. It's got 4 AND gates, 3 NOT gates, and an OR gate right here. When no switches are on, it's on. 1 on. 2 on. 1 and 2 on, it's still on. Just 3 is on, it's off. 3 and 2 on. When all of them are on, it turns off. And I also have pictures of all of the inputs and outputs for each of these problems in the Excel document. Thanks.